Hey friends, we have some news from our sponsor Text Control. They just released version 32 of their document processing library, which includes new core functionality such as document footnotes, SVG export, and more. You can integrate document editing, signing, collaboration, and PDF processing into your ASP.NET Core and Angular applications with Text Control. These powerful libraries will let your developer teams focus on their core competencies, while Text Control handles your digital document processing. Check out all the new features and see the technologies live in action by visiting the demo at demos.textcontrol.com. That's demos.textcontrol.com.
Hi, I'm Scott Hanselman. This is another episode of Hansel Minutes. Today I'm chatting with Damian Edwards. He's a principal architect at Microsoft working on .NET Aspire. How's it going, sir?
Oh, building product, doing the .NET stuff, all that good fun. How about you?
I'm getting there. I think we're both a little Monday right now. For those of us who are listening, we're having a case of the Mondays, but the work continues and the good work continues. So .NET Aspire is this new thing that seems to have captured the imagination of the .NET community. It's really interesting, and it's starting to get outside the .NET community. I'm noticing people start mentioning it more and more. I think it's always interesting because Microsoft's not well known for naming things well, and it doesn't exactly tell you what it is. Certainly the word Kubernetes doesn't exactly tell anyone what it is either. But what is .NET Aspire, and why should anyone care?
Yeah, the truth is explaining what Aspire is can be challenging because it's not one thing. It's not like a new web framework that you use to build web pages like Blazor is or was. And it's not like minimal APIs, a new way to build APIs in ASP.NET Core. And it's not even something like a new ASP.NET Core, so to allow you to build new apps for new modalities or whatever it might be. It's literally a collection of a few things spread across 4 or 5 pillars, depending on who's talking about it, that collectively the end goal is about helping you build distributed applications better. Now, the marketing term and like the current industry trend is to use the term cloud native, but cloud native means different things to different people. Some folks hear cloud native and they think, oh, it is attached to Kubernetes. It has to be attached to Kubernetes in order to be cloud native. Other folks will hear cloud native and think it means, well, that means it can only run or only help me if I'm running on a public cloud. The reality is it's just about building distributed applications and then kind of borrowing or acknowledging a lot of the recommendations that have emerged over the past half decade to decade as people start running more and more apps in the cloud or at large scale about what constitutes a good app in those places. And maybe that's a loaded term. Maybe it's more like what's going to help you be productive, what's going to help you be reliable, what's going to help you scale well when you start building apps and deploying them in this way versus, what we did 20 or 30 years ago, I guess, if we look at the epochs of how we built these types of applications. So it's templates. It's a bunch of new NuGet packages. It's a thing called an orchestrator, which we can talk a little bit about. And it's a full embracement of open telemetry in order to make your app a lot more observable, both during the development time, like on your local machine, as well as after you've deployed it to production.
Okay. All right. So let's unpack some of these things. This is a super helpful place to start. So we hear the words cloud native. We hear the words cloud ready. I have always been surprised that we don't simply say cloud aware, because all of those terms to me just mean, does your app know it's in the cloud, or is it being lied to so completely that it has no awareness of the cloud? Early web apps naively lifted and shifted. Like if you run your web app on IIS and Windows Server and you move it, quote unquote, to the cloud, meaning you lift up your VM and you throw it into a VM in the cloud, the app has no concept that the cloud exists. If you have an Azure storage account or an AWS storage account and you map a drive, like the D drive in your VM, once again, you're hiding the cloud. So that app is not a cloud native app. It is being effectively lied to. Is that a fair statement so far?
I think it's a fair viewpoint. I think there are other perfectly or as valid viewpoints about what constitutes an app that's cloud native. But I think it makes total sense to say, well, it can't really be cloud native if it's not natively taking dependencies on things that are only available in, quote unquote, the cloud. But that has other drawbacks as well. So that people care about sometimes like multi-cloud scenarios where they want to have an app that can seamlessly run on one cloud versus another. So they want a layer of abstractions. Like it's funny because you said architect of Aspire. Architecture is basically just operating at different levels of abstraction and either inventing or removing levels of abstraction to make a different set of trade-offs. That's all it really is. Throw in some product kind of sprinkle dust in there as well. And so cloud native to one person might look different to cloud native of another person. And I would probably argue that you can be doing cloud native even if your app isn't directly talking using the client SDK of some proprietary cloud service, because there is kind of a generalized set of things that have evolved out of the modern cloud native sort of architecture movement that are really just continuations of distributed application design, which has been something that's been evolving for literally decades, like 40, 50, even 60 years.
Yeah, I was doing distributed apps in DCOM and COM 20 years ago, and it was all about lying to our app because we had location transparency, and we would pretend that the network had no latency.
Right.
We would pretend that these objects they just exist. They're in the ether. But now there's a formal recognition, like DNS is a thing and we depend on it. And HTTP is a thing and certs are a thing and we know that they exist.
Right. Well, and it's that, which is absolutely true. But then there's also kind of the flip side of that coin. Like DNS is a really interesting example, because then there's also DNS exists and I'm going to exploit it by lying about what DNS actually is. So now I'm going to think my app thinks it's talking to DNS, which is probably some remote server that result in its mind. But in reality, I've just hijacked the client side of the DNS resolution pipeline, and now I'm lying to it about where to actually talk to in order to leverage that as a new layer of abstraction.
Yeah, actually, that's a great example. This is a weird analogy. Tell me if this works or not. But like when REST said, hey, get, post, put, and delete, I'm adopting those. Those were never intended to do this, but I'm going to go ahead and say that they're CRUD. With DNS, we're like, hey, we have this whole lookup table here, this wonderful distributed hash table that goes from domain names to IPs. I'll just pretend that it's locally in memory here, and we'll just have an orchestrator lie to everyone. And that's a thing now. I mean, Kubernetes really exploited DNS to its fullest.
Right. And so it might be that now, at the layer of abstraction that your app code is running, when you logically make a DNS request, you wrote that as the developer, or the application executes that in the context of, I'm going to call out to, the OS or the platform I'm running on is going to do its DNS thing because I know I'm running on top of TCP and all the rest of it. And then I'm going to get back some address or some result of that query. But as you just said, you literally called it out. DNS is a database, right? And you can have records of different types. So it has a schema, and that means you can extend it with different things, even if a lot of those schema elements have not been used in the vast majority of cases in the history of the way that we think about DNS. But that is utilized today in the world of Kubernetes and lots of other systems where you can put data in this distributed hash table, as you called it, or synchronized hash table, in order to change or get a distributed configuration system. That means your app code doesn't have to change if you want to change some aspect of how your app is going to run after you've deployed it. And again, that's all just layers of abstraction and trade-offs. Turns out there was an existing system that almost everyone has deployed called DNS, which we know how to administer, we know how to make reliable, continues to evolve as the needs of the things that sit on top of it mature. Hey, we can use that in a slightly different way to get a different outcome. And REST is another great example of where something that has been there in plain sight underneath, someone took a slightly different look at it and said, you know what, we could use this plus all these little bits of these extensions and just formulate a new or codify a new quote unquote standard of how to think about this. And then leverage that. Now, REST was that and a whole bunch more, and I don't want to get into all the rest of it because I know all the rest of people will get angry. But that's, broadly speaking, that's really what we're doing here.
Yeah. It is funny, though, they have all of this historical context. And in my mind, I'm thinking, well, in COM and DCOM, you'd go from a class identifier, you'd look it up in the registry, and you'd get to a GUID, which would give you the object that you wanted. And now we're looking up with a URI, arguably not a URL, but a URI, that may or may not exist, like, HTTP whack shopping cart. It's just, I want to talk to the shopping cart. I don't know where it is. I'm going to trust the orchestrator to just handle that for me.
Right. And just to put a bit more context with a name around this and bring it back to Aspire, what we're talking about here is service discovery, right? So this is one of these pillars that we talked about. And these pillars, we, as a product team, we take a few steps back again, why did we even start doing this? Well, it turns out when we spoke to customers or observed customers building .NET apps and then deploying them in these hyper-distributed scenarios. I mean, let's just say the cloud, but that's really what we're talking about. It could be on premises running Kubernetes clusters, but it's basically hyper-distributed. What were the challenges that they ran into? And here's a very common one that developers run into. It's like, well, just to get service A to talk to service B, which talks to some messaging system or talks to some database, I have to think about addresses. I have to think about TCP. I have to think about firewalls. I have to think about all this stuff. And when it comes to onboarding perhaps younger developers, this is also a challenge that we've observed, which is you just, the first day that you want to be able to show this person, write this bit of code over here, like literally 5 lines, and then write this other 3 lines on this other side, and they can talk to each other. Well, guess what? You try and say something like, well, it's using the loopback address, so you don't need to do a firewall rule. This will be fine. And their eyes glaze over. And so you just take for granted all this context that you have, sometimes decades, of what it takes to have 2 processors, even on the same machine, talk to each other using TCP IP or a higher level thing. And so service discovery is really just about saying, as you said, give it a friendly name that me as the developer understands, and then plumb it through some system that, again, is familiar to the developer. It could be DNS. It could be a C# API if you're a .NET developer. It could be a configuration file if that's what's common to you. It's really just about abstracting simple name, how does that get resolved, to something that the actual machine can use to talk to the other side.
And to abuse Arthur C. Clarke's famous quote, each additional layer of abstraction is indistinguishable from magic. We need some kind of maturity almost, or kind of a collective acceptance in the computer science and in the software engineering community when a thing like Aspire or Kubernetes comes along and starts to hide stuff from people. So you just said for the younger developer, and what we mean is for early in career developers, full stack is a lot. Like, okay, I want to make an app. What's it going to do? It's going to have login and do a shopping cart. Okay, before we can teach you any of that, let's talk about YAML. Let's talk about DNS. Let's talk about HTTP. There was if .NET Aspire was created 10 years ago, the moment might not have been there. Like we might have said, you're hiding too much. But it feels like the community has become frustrated with the amount of stuff you got to know. And they're like, okay, I get it. Fine. Now hide this from me.
Yeah.
You know what I mean? So I feel like the tooling met the moment, and we're okay with some of the administrivia being hidden from us.
Yeah, I think so. I think, honestly, there's always been an acceptance for abstraction layers, which is effectively what we're talking about here, right? We're just saying I'm operating at some logical, contextual level in the modality that I currently am. I'm saying these words, and that means something in this context. But we kind of consciously or subconsciously understand we're standing on top of many, many other layers underneath us, whether it's saying we're standing on the shoulders of giants, or whether all those who came before us, or just some logical model or physical model. But I think there's also good ways of doing that. Words like good can be problematic, but there are different sets of trade-offs that can be made with one approach of doing that, of abstracting and quote-unquote hiding stuff, and other ways that perhaps people equate to just being magical and not actually well architected. And to give some more perhaps concrete examples from the history that you and I both have in common, let's look at .NET. So Web Forms was an incredibly productive web framework, and I think was very successful in setting out what it achieved to do, which was make developers who are familiar with a certain style of application development be productive very quickly in a very different style of application development. And that was basically built around a very complicated architecture under the covers, some of which was exposed if you wanted to be, and other parts that were kind of more black box, and then some very rich tooling that helped with that as well. And I think after a little bit and the web evolved, there was some backlash against that style of web framework for being too magical, hiding too much. And I think the real sin, making it too difficult to break free of the abstraction, to punch through the abstraction layer and say, you know what, I understand what's going on here, but I need to tweak this one aspect of what you're hiding from me right now. All that is a long way of saying there's a good way to hide and a bad way to hide. And what we're really striving to do when we build these experiences now, whether it's ASP.NET Core, 10 years ago, or minimal APIs 3 to 4 years ago, or now Aspire, is we want those layers of abstraction. We know and we understand that they help with productivity, they help with onboarding, they help with flexibility, they help with extensibility. But we need to do it in such a way, and this is where the job of the architect comes in, such that we're not, throwing the baby out with the bathwater or hiding so much stuff or making it so difficult to punch through that when you get to that 20% case of kind of that 80-20 rule, it's just impossible. It's like, well, I need to do this. Sorry, the abstraction does not allow you to do that, and there's no way to operate outside the abstraction. And so we continue to evolve, and that's where we rely on feedback from customers to really tell us whether we've got that right. But we like to think that that's what we're doing. And so my message to folks would be, and I think you were kind of alluding to this, was that if it looks magical, and I know you talk about this a lot as well, take a moment, just take a little bit of time to step back and try and understand what's going on one layer beneath what you're looking at right now. And often that will be the key to unlocking the whole picture for you in your mind, and you'll suddenly see where the abstractions exist and whether it's been a good implementation or a bad implementation.
Yeah, this is perfect. Okay, so now, if you've made it this far into the podcast, let's get real. HanselMinutes.com is an ASP.NET application that runs in a container in Azure. Right now, it has some external data sources. Let's say I want to add Redis for caching, and I want to add Postgres. If I did not use .NET Aspire, I would fire up some Redis service, or I'd fire up a container with Redis in it. I'd have to figure out how to do that. I'd have to deal with some secrets, some keys, some APIs. I'd figure out how to address that Redis thing, maybe directly. I think I would probably make some configuration options, maybe an environment variable. I have to start thinking about that. All of that is kind of yak shaving before I can actually go into the Redis stuff. And then I have to do the exact same thing for Postgres. Is that all fair so far?
Yeah, like as you said, like the first thing is like, okay, I need to stand up a Redis. And we're still assuming an awful lot just making that statement, right? It's like, okay, how do I connect to it? Let's assume that I know that it listens on a port. What port does Redis listen on by default? Well, let me go and find that out. Now, I could figure all that stuff out by, searching and all the rest of it.
Yeah.
But if I just want to get some cache working right now, wouldn't it be nice if I could just say, can you add a Redis cache for me and please make it work?
Okay. So I could go and do all of that with my ASP.NET app. My ASP.NET app already exists. At any point, though, I could probably make some mistakes. Maybe I would be dealing with the keys in an insecure fashion. There'd be a number of like best practices and a little naivete on my part that may cause me to do something wrong. So when we say that .NET Aspire is opinionated, I'm assuming it has a strong enough opinion to want to do things right and simple and in some kind of formalized best practice prescriptively by default.
Yeah, that's kind of the idea. So like some other decisions that you would have to make, or perhaps you implicitly made without even thinking about them if you set something up like Redis by default, is you would choose a Redis client. Like I'm using .NET, so I need a library to add to my application to talk to Redis with, because .NET doesn't have native support for talking to Redis. I mean, in our community, there is basically one library that everyone uses, with stackexchange.redis. But if you didn't know that, and you go to NuGet.org and you type in Redis, it just sorts by downloads, right? Like that's what it does by default, and that's what it uses as a proxy for, quote unquote correctness. How relevant is this result? But there's a lot of results if you search for Redis. Now, you could also very understandably, you might search for Redis ASP.NET or ASP.NET Core Redis as a package, because a certain type of customer or a certain type of user might think that they're an ASP.NET person, not a .NET person. And so that's what they would search for. And you would get different results depending on what you type in. So just getting the client is one thing. Now, once you've got the client, now you have to figure out how to use the client. Okay, well, how do I use this Stack Exchange? Let's assume we got stackexchange.redis, which is the one that you want. How do I use it? Well, it'll have its own documentation on its own website, which makes sense. And let's assume that you can find that. And hopefully it has some examples. And it might even have some example that you zero on quite quickly, specifically about the context in which you're going to use it, which is I'm going to use it in ASP.NET Core and I'm going to use it for caching. Now, that's a big R. I already made quite a big leap that you got there that quickly. I would hazard a guess you will not get there that quickly. But let's say that you did. ASP.NET Core has a DI system. It has a configuration system. It has a logging system, much of which is built on top of the hosting abstractions in .NET. Does Redis integrate with any of those? Well, no, not by default. If you want them to integrate with that, you have to write the shims to do that yourself. You have to make the left hand match up to the shape of the right hand and then join them together. In fact, before we started the Aspire effort, the Stack Exchange Redis client for logging, if you wanted to get logs out of what it was doing, you passed it a text writer. which is like a very low-level primitive in .NET for a thing that you can push text into. So you would have to create an instance of a text writer, pass it in at the very top level of the hierarchy of their API, and then it would write outputs to that. Now, that doesn't map to the ASP.NET Core's logging system by default.
Right. And all of this has nothing to do with the business problem, which is I'd like my podcast to have a Redis cache.
Well, the business problem was probably even higher level, right? It's like I want the homepage of my podcast to be quicker because it's doing redundant things every time.
So I want a thing. I want a Redis cache. I want a Postgres. I want a service bus. And then to your point, health checks, logging, telemetry specific to that. And I would I don't want to have to think about that. I want to be able to say, I'd like this service. So .NET Aspire provides those things as .NET Aspire components, basically a standard NuGet package for these services, these obvious top services. Now, is it every service? Is it like, what if there's a database I've never thought about, like Couchbase or something, that doesn't have one of those? Is that something I could write my own?
You absolutely could. So yeah, we have to acknowledge that another part of Aspire was kind of trying to bootstrap create a bit of a gravity well around this kind of idea of how can we make pulling together a set of ideals for distributed app design in .NET a little more central, a little easier to find, and put some practices around it. And when I say practices, you're saying opinionated. That's what our marketing stuff says. What are these opinions? The opinion is something as simple as if you add the Aspire component for Redis, rather than it simply adding a library that lets you talk to Redis, it adds that when you call the method in that Aspire component, it adds it to the DI container in an opinionated way. It adds it with a specific lifetime because DI has a whole bunch of settings that you can configure. So the default is it does it a certain way. Then it by default hooks it up to the configuration system so that all the options for that API that you would usually set in code, you can now set from your configuration system, which includes JSON, environment variables, all the normal things that we're used to in ASP.NET Core or .NET hosting. Then things like telemetry and health checks. Well, again, the Redis client doesn't include support for the .NET health check system. That's in another package written by another person on another GitHub repository with a different NuGet ID. So the Aspire component references that for you. We made a choice. We had an opinion, and we said, well, this is the prevalent health checks library or suite for doing sort of extra health checks for all of these services. So we're just going to adopt that. And when I say adopt it, I simply mean we're going to reference it from our NuGet package that we built. Like it's a community. This is what this is. It's an ecosystem of lots of great stuff, but we're just helping pull stuff together in a way so that you don't have to make that decision every single time. And when you call the method, it's all on by default. And the last part is the OpenTelemetry stuff. So OpenTelemetry is probably worth talking about a little bit more, which is this industry effort sponsored by Google and Microsoft and other telemetry vendors like APM vendors and things like that. And it's about basically coming to an agreement about, hey, if a system wants to emit telemetry about how it talks to a database or how it talks to another HTTP service or what it does when it starts up, et cetera, maybe we should standardize that. And what does that mean? Well, it should have a standard event name. It should have a standard schema. They should have standard protocols. So if you want to send that telemetry via HTTP with JSON, it should look like this. But we should also support sending it over HTTP with gRPC. And in that case, it should look like this. And then we should do that in a collective way as an ecosystem so that I can build telemetry into my app, and then I can pick it up from one place, point at that telemetry egress to some totally other telemetry ingress system. And as long as it speaks OpenTelemetry, it'll work. And so we've taken a bet on OpenTelemetry because .NET supports OpenTelemetry. We have primitives in the .NET framework and the language that map to the OpenTelemetry primitives. So when I say we adopted OpenTelemetry, there isn't like in the core of .NET types that have the same names. No, we have things like iLogger, which maps to the OpenTelemetry concept of logging. We have things like meters, which OpenTelemetry has a thing called metrics. So we hooked those up to each other. And then we have something called activities in .NET, which is what we use for doing distributed tracing. That is tracing that can go across process boundaries, across machine boundaries. And that gets hooked up to OpenTelemetry's concept of tracing through the OpenTelemetry.NET libraries. And so we pull all that stuff in for you by default when you use our components, so that when you add your Redis, going back to what it is that you want to do, you know it'll be instrumented for OpenTelemetry by default.
Right. And OpenTelemetry, also another example of something that's having a moment where the software engineering practitioners community has finally said, okay, we're done writing to a dozen text files. Let's have a bus of some kind. Let's standardize how telemetry is collected and transmitted to our backends in a way that is open source and that is vendor neutral, with a formalization on the idea that components should be observable. And in doing that, that means that I could theoretically have a .NET service, I could have a Redis, a Postgres, or maybe a Python service or a JavaScript. Like I assume that .NET Aspire could talk to non.NET things, because it is when it's talking to Postgres and Redis.
Yeah, 100%. So first of all, yes, everything you just said about OpenTelemetry is true. And then I would add to that, the other critical part is that we want to make sure that it's growing up in the real world, that it's battle tested with real things. It's not just pie in the sky architecture that would be great if everyone, designed in a closed box. As I said, it's actually being built and standardized by an ecosystem that includes players like Google and Microsoft and the big APM vendors. So that's great. When it comes to Aspire and sort of heterogeneous environments and like stack, one of the key aspects of Aspire is this orchestration, this development time orchestration piece, which we haven't talked about yet. When it's actually kind of the key building block that really unlocks the whole development experience. So Aspire is very unapologetically .NET and developer first. So it is intended primarily to improve the development lives of developers, that developer inner loop experience. It stretches beyond that. We have things to help with deployment, and a lot of that stems from this orchestration piece. Now, we call it the AppHost. It's a new project type, very .NET-like. You add a new project to your solution. It's the Aspire AppHost project. And inside that, you have a C# file, and you write code that describes your distributed application. So ever since .NET 6, we've had this ASP.NET Core sort of minimal hosting layer, this type called web application. And in the very first line of your program, CS is this web application.create builder call. And then what's returned from that is an object that you can call things on to add services to DI. And then you call build, and you get this application object that you can use to map endpoints using minimal APIs. And then you call run. So we call that kind of the host builder pattern. So we have a host builder pattern for distributed applications now. We go, okay, well, what are the things that you add to the builder for distributed applications versus the thing that you would add to a web application? Well, you add containers, you add executables, you add parameters, because there might be input coming from the host that you can't codify a value for in C#. It's that I need to leave a space here for a value to be provided by my environment, but then I can create references between these things. We call them resources. A container is a resource, an executable is a resource, a .NET project is a resource, a Node.js application is a resource. And then we allow you to sort of configure these so that they talk to each other effectively. I can say this resource has a reference to that resource. And if the code looks very elegant, I think, like it's very much, I add a thing to the model, and then I can say this thing references that thing with a very common set of sort of new terms or vocabulary that should look familiar to people who use modern .NET.
You're building a dependency tree. You're expressing.
It's exactly right. You're building a dependency tree or a graph, as it might be. You can have cycles. You can have lots of different branches that go off in different ways. And then at the end, you call run. And then when you hit F5 in Visual Studio or VS Code or type .NET run at the command line, you run that project and it runs everything for you. It literally boots up and configures everything for you when you run it.
And if you've got Docker on your machine, it spins up the containers that are necessary. And when you break out of your debugging experience or your local experience, those things go away.
That's right. So at the moment, the life cycle or the lifetime of these sessions is tied very much to, again, the .NET-centric application lifecycle. So you launch in Visual Studio or you .NET run at the command line, that starts a new session, and everything runs for as long as that session runs. And when you finish that session, either by stopping the debugger in Visual Studio or hitting Control-C in your terminal, then everything gets torn down. Now, one of the first biggest pieces of feedback that we've had actually since we launched is that's too simple. Like, people want more control over the lifetime, very much so, of especially things like containers. So they want to be able to say, yes, I want you to create this container for me, but don't shut it down. I'm going to shut down the host. It's fine just to keep it running and then find it the next time. Now, that sounds really easy. It's actually a very hard problem to solve reliably, but that's one of the big pieces of feedback that we've heard and that we're trying to improve for upcoming versions.
Yeah, I saw that with my application that fires up Postgres and has to build the schema, load the thing with test data. It adds 10 seconds to my startup. If I just kept it running or did that, outside of the environment, it would be a lot easier.
It would be. And so to be clear, we have primitives that let you collect, or building blocks that let you connect to existing instances. So if you don't want to manage the container from Aspire, you can just connect to it. So you can, rather than adding a container to the model, you can add a connection string to the model.
Right.
Then just point to the connection string. Now we get back to this comment we were making about layers of abstraction before. That's one layer lower. So the highest level is you say add Postgres, and you give it a name and you give it no other arguments.
And a miracle happens.
And then a miracle happens, and you also wrote a line that says, give this Postgres to this .NET application. And the miracle that happens under the covers there is it somehow configures that application to know about that Postgres. Well, what's happening one layer lower? Well, that add Postgres method just calls the add container method with a set of values. What values? Well, the value that is the name of the Postgres image and the tag to use. And it wraps it in a class that says, hey, I can provide a connection string. So if anyone references me and they can consume connection strings, can you please inject my connection string information into their environment variables? So that project, the way it was being magically configured, was very simply by virtue of the fact that Aspire injects an environment variable into that application when it starts its process, when you hit Frun, in a schema that's already understood by .NET applications. So most people are probably aware, if they're using .NET today, that when you want to get a connection string out of the configuration API, there's literally a method called getConnectionString on the configuration object. And all that is a layer of abstraction that says, go and get a configuration value where the beginning is in the connection strings section. That's all it does, right? These are all just, what's the word? The nice little APIs on top of very rudimentary sort of standards that you would have done anyway if we hadn't have built the higher level API for you. So we're just looking for the boilerplate and then kind of codifying that as the way that you do it and giving you a nice method to achieve that. But it's built on a lower method. If you don't like what it does, F12, which is in Visual Studio, go to definition. It'll pull in the source code for you from SourceLink, and you can look at exactly what it's doing. There's no better documentation than the actual code. And the code is actually fairly straightforward. It's literally just setting environment variables through a bunch of interfaces. So if you can understand C#, you can pretty much understand what Aspire is doing in this AppHost project.
Very cool. Okay, so wrapping this all up into a nice little bow in the last few minutes here. So that my current existing podcast website, which is just running in the cloud in a container, I add this, I make it an Aspire application. The host starts up, it fires up Redis, it fires up Postgres, and it fires up my existing podcast site. And then when I deploy that to a cloud, whether it be Azure or another cloud, if that cloud can spin up containers, the app kind of runs as per usual, right? How does .NET Aspire spin up those things or connect to those resources?
Yeah, so I will say everything I've talked about with orchestration is almost predominantly a dev time thing. This is about improving the development experience on your local developer box. In your scenario where you've got an existing site and you want to use Aspire to improve the development experience, it can literally stop there. So you can say, I already have all the stuff running on my cloud. I'm not going to change anything about how I deploy, like literally zero, nothing. I already have my database. I already have my Redis, or I can manually create the Redis. I don't need to go and create a script for it.
Okay. I don't need to turn over the keys to the city.
Right. And then I'm just going to deploy the application the way I already deploy it, whether it's in a container.
Yeah, I have a very good CI/CD that already works.
Right. So you don't have to change anything, nothing at all. You can just add Aspire to make your local development experience much, much, much easier. So you don't have to think about when you hit F5, is my Postgres server running? Is my Redis server? Do I even have a Redis server on this box because I've got some new laptop? All that goes away. Or you can look at what Aspire can do for you by taking all that information that you wrote in that AppHost C# file and then piping that through to what we call a deployment manifest and feeding that into a tool chain that understands how to read that manifest. Right now in Azure, there's a tool, the Azure Developer CLI, that has been updated to support Aspire. The Amazon folks are working on a set of tools for their tool chain as well. And then there's a community tool called Aspirate, which does it for Kubernetes. So if you want to take like a full Aspire solution, that's 100 containers with a whole bunch of things and just point it at something and say, give me Kubernetes at the other side, the Aspirate tool can do that for you as well. But I want to make it very clear, you don't need to use any of that. You can just keep deploying the app the way that you deploy it today and just add Aspire to get all the benefits as a developer.
Very cool. Rock on. Well, this has been super helpful. It gives me a lot of context. Hopefully, it will give the folks that are listening additional context. You can check out the source code for .NET Aspire at github.com/dotnet/aspire. And of course, there's a link directly on that GitHub page to the documentation and get involved in the community. And there's a ton of YouTubers as well talking about .NET Aspire as well. So check them out if that's how you like to learn. Thank you so much, Damian Edwards, for chatting with me today.
Thanks, Scott.
This has been another episode of Hansel Minutes, and we'll see you again next week.